Okay, so lesson 70 is about probability. Probability is the likelihood or chance of an event occurring. For example, the probability of flipping a coin and it's being heads is 1/2 because there's one way on a coin with two sides. There's one way of getting head, and the total number of things you could get would be 2, a head or a tail. So we write the probability of heads, P with heads in parentheses, is equal to 1/2. So probability and statistics, this is just a branch of mathematics that talks about counting the number of ways something can happen to give some kind of idea in a person's mind about how quote unquote likely that thing is to happen. It's kind of just a way of giving an idea of what one would expect, but it's not an exact science. It doesn't work out this way in real life, but it's just kind of giving an idea of what you can expect as far as how it all works out with how many ways there are for something to happen and how likely that thing would be to happen. All right, so the probability of an event is always between 0 and 1 because it's either, it's impossible for it to happen, or it's definitely going to happen, or something in between. So there's never more than a 100% chance that something's going to happen, because 100% means that it definitely will happen. And there's never less than a 0% chance of something happening. 0% means it's not going to happen. So every probability will be between 0 and 1. And like I said, an event that is certain to occur has a probability of 1 or 100%. Means the same thing, and an event that cannot occur has a probability of 0. All right, so for example, first of all, the way we talk about probability, we talk about it as a ratio, where the numerator, so the probability of a particular event, the numerator of this fraction is the number of outcomes that satisfy the requirement, so the number of ways that event could happen. And then the denominator is the number of all possible outcomes. So for example, if you look at the spinner on the top left, the probability of spinning a 5 on that spinner is 0 because there are no 5s on there, and you can't spin a 5. There's not even one way to spin a 5 on that thing. So it's just 0. It is absolutely impossible to spin a 5 on that first spinner. The second spinner on the bottom left, the probability of spinning a 2, right? There's one way that you can spin a 2. There's just one triangle there that has a 2 on it, so that's your numerator of your fraction. And then the denominator of the fraction is the number of possible things you can spin. There are 8 possibilities, 1, 2, 3, 4, 5, 6, 7, and 8. Only one of them is a 2, so the probability of spinning a 2 would be 1 over 8. One way to spin a 2 over 8 total ways for that event to happen. 8 possible things you could spin. So that's pretty unlikely. You can't really predict that when you spin that you're going to get a 2. It's somewhat unlikely. All right, if you look at the middle spinner, it just has 2 numbers on it. They take up equal space, a 1 and a 2. If you spin that spinner, it's just as likely you'll get a 2 as it is that you will get a 1. Because there's one way, to spin a 1, there's one way to do it, and there are 2 possible outcomes. So there's an even chance of spinning a 1. One way to do it out of 2 total ways, 2 total events that could occur is 1/2. Then if you look at the bottom right spinner, the probability of spinning a 1 on that is very likely because there are 4 ways to get a 1. You can get a 1 in any of those 4 regions, and then there's one more region. There's a total of 5 regions. 4 of them are 1s, so the probability of spinning a 1 is going to be 4 over 5. It's very likely because there's 4 ways to spin a 1, and there are 5 total possible outcomes. So the probability of spinning a 1 is 4/5. And then on the last spinner, up on the top right, every single place is a 1. So the probability, or spinning a 1, the probability of spinning a 1 is 100%. You're gonna spin a 1 when you spin that. We're not considering the possibility that it'll land on a line, but you are going to get 1 no matter what. So that is a certain probability. All right, so a fair coin is tossed 3 times and comes up heads every time. What is the probability that on the next toss it will come up heads? Well, the first 3 tosses do not affect the 4th toss at all. It doesn't matter how many times you tossed it before. Whenever you toss a coin, the probability of it coming up heads is always the same. It's always 1 out of 2, or 1/2. There's 1 head, and there are 2 possible things you can flip. So that's always the probability of flipping heads, no matter how many heads or tails you've tossed before. 6 green marbles and 8 red marbles are placed in an urn. 1 marble is drawn and then dropped back into the urn. Then a second marble is drawn and dropped back into the urn. Both marbles were red. If another marble is drawn, what is the probability that it will be red? All right, so if you take one of these out and then put it back in, and take it out again and put it back in, that's not going to affect anything. That doesn't change the probability of drawing a red. All right, so it doesn't matter what you do previously if it doesn't affect what you're about to do. All right, so there are still 8 red marbles in there and 6 green marbles. So the probability of drawing a red marble is the same as it was in the very beginning. You've got 8 red marbles. You've got 6 green marbles, so that's 14 total things you could pull out, and 8 of them are red. So the probability is going to be 8 over 14. 8 red marbles, 14 total marbles. So the probability of drawing a red is 8 over 14. In other words, 4 over 7. All right. Now, a single die is rolled 3 times. The results are 1, 4, and 3 in that order. What is the probability that the next roll will produce a number greater than 2? Well, again, those first 3 rolls they don't affect anything to do with the next thing you roll. They happened and they're over, and the probability of getting a number greater than 2 is not affected at all by the first 3 rolls. So really the question is, what is the probability that when you roll a single die, you're going to get a number greater than 2? Well, there are 6 possible things you can get, so your probability of rolling something greater than 2 will be out of 6 possible things that can happen. 1, a 2, a 3, a 4, a 5, or a 6. And the events that are greater than 2 are going to be 3, 4, 5, and 6. So there's 4 possible rolls that are greater than 2. So the probability of rolling a number greater than 2 is going to be 4 out of 6, or 4/6, which is reduced to 2/3. All right, so in that problem, again, those previous events do not affect the event you're talking about in the last sentence. That doesn't affect anything. It just makes you think something's going to happen, but it doesn't change the facts. The facts are that there are 6 sides to a die. Those are the 6 possibilities of what you can roll, and there are 4 numbers greater than 2 that you could roll, so the probability of rolling a number greater than 2 is 4 out of 6, or 2/3. Now, sometimes, actually, we're not there yet. In this next problem, you're rolling 2 dice at the same time. All right, so if you roll 2 dice, there's a lot more possibilities than just 6 answers. Okay, when you roll 2 dice, you can get anything from a 2 all the way up to a 12, because you add the numbers on both dice. All right, so you can see this chart here helps us see all the possibilities that you can roll. If you roll a 1 and a 1, you get 2, a 1 and a 2, you get 3, a 6 and a 3, you get 9, and so on. So this shows us all the possible numbers you can roll with 2 dice. So what is the probability that the sum of the numbers rolled is going to be 7? Probability of 7, if you look at your chart, you've got 7s all the way down this diagonal. 1, 2, 3, 4, 5, 6, 7 ways to get a 7. You can have 1 and a 6, a 2 and a 5, a 3 and a 4, a 4 and a 3, a 5 and a 2, a 6 and a 1. There are that many ways to roll a 7. So that's 6 total ways to roll a 7 divided by the number all the numbers you could roll. There are 36 of them. All these numbers in the chart. There's 36 numbers you can roll with 2 dice. So 6 out of 36 is 1/6. The probability that you'll roll something greater than 8, look at all the numbers that are greater than 8 in this chart. Those are all the events that will give you a number greater than 8. There's 10 of those. So that's 10. Probability of getting a number greater than 8 is 10 over 36, or 5/18. Now, sometimes you want to find out the probability of several things happening in a certain order. All right. So, and we're talking about now or events that don't affect one another. Right. We call them independent events. All right. Several events that have nothing to do with each other, happening in a designated order. When we try to find out the probability of that kind of a sequence of events, all we have to do is look at each individual event and get its probability, and then multiply the probabilities of all the events. So it'll make more sense with an example probably. So for example, if I flip a coin twice, right, I'm going to flip a coin twice, and I want to know what the probability is that I'll get heads first and tails second. All right, so I want to know what is the probability of this sequence of events happening, that I would I'd flip heads first and then a tails if I flip a coin twice. And what you find out, which I'm going to show you why in just a second, but the probability of flipping heads first and tails second is just the probability of flipping a head, which is 1/2, times the probability of flipping a tail, which is also 1/2. You multiply them together, and the probability of getting heads first and then tails is 1/4. And I'll show you why that works. All right, so look at this diagram. All right, so you're going to flip a coin. The first toss is represented by the first row here. The first toss could either be heads, so right here, or it could be tails. So that's your first event. One of those two things can happen. All right, on your second toss, if you flipped heads the first time, you could still flip heads or tails the second time. And if you flip tails the first time, you can get heads or tails the second time. So here are the possibilities when you toss a coin twice. You can either get heads first and then heads again. That's one possible thing that can happen. Or you could get heads first and then tails second. So that's another possibility when you flip a coin twice. Or you could get tails first and then heads. That's another possibility. And finally, you could get tails twice. First time tails, second time tails, 4. So there's 4 ways this thing can happen. If you flip a coin twice, you can get heads. You can get heads, heads. You could get heads, tails. You could get tails first and then heads, or you could get tails first and tails second. All right, so the probability of getting heads first and then tails, which was this possibility right here, heads first and then tails, is 1 out of a total of 4 possibilities. So the probability of getting a head first and then a tail is 1/4, and so that fulfills what we said about the first situation, and that is that if you want to know the probability of two things happening in order, you can simply multiply their individual probabilities as long as they don't affect each other, and the two flips don't affect each other. You flip it once, pick it back up, and flip it again. All right, so whenever you have a sequence of events that you want to know the probability of that sequence of events happening, you can simply multiply the probability of each event. So we found out that 1/2 times 1/2 is 1/4, and that's what we saw here, that there really are 4 possible ways this could happen, and only one of them is heads, tails. All right, a fair coin is tossed 4 times. What is the probability that the first 2 outcomes will be heads and the last 2 outcomes will be tails? All right, so we could draw a big diagram of this, but it would be complicated and it would be a waste of time, because we already know that all we have to do is multiply the probabilities of each thing happening. So the probability of getting heads, heads, tails, tails is just the probability of getting heads, 1/2, times the probability of getting heads, 1/2, times the probability of getting tails, 1/2, times the probability of getting tails, 1/2. So 1/16. And if we drew a chart, it would look just like the one that we looked at before. It would have all these branches, and it would turn out there would be 16 possible ways this can happen. And only one of them would be heads, heads, tails, tails. All right, the spinner shown is spun twice. What is the probability that the spinner stops on the 4 and then on the 3? So we want to know, you're going to spin it twice. What's the probability of getting a 4 first and then a 3? All you have to do is multiply the probabilities of each one. The probability of getting a 4 on this spinner is 1/4, because there's a 4, there's one of them. That goes in the numerator, and then there are 4 possibilities. So 1/4 is the probability of getting a 4. The probability of spinning a 3 is also 1/4. There's 1 3 on the spinner. There are 4 possible things you can get. So the probability of spinning a 3 is also 1/4. And now, to find out what the probability of spinning a 4 and then a 3, you just multiply their two probabilities together, and you get 1/16.